Let's do a little thought experiment. Let's look at an extreme example where we vastly increase the solar energy generation capacity in the Northwest Territories of Canada. Here we will look at the current electricity generation mixture of the Northwest Territories. As of 2015, the electricity generation in the Northwest Territories is supplied by 5 main sources. Diesel fuel generators supply about 68% of the load. Hydro generation, which comes in second, supplies about 20% of the load. Natural gas generators supply about 8% of the load. Wind farms supply about 3.5%. And finally, solar generation currently supplies about almost 0.5% of the load. This graph shows the costs associated with the various generation systems supplying the load. The levelized cost of electricity, or LCOE, is average revenue generated by the technology per unit of electricity generated. This value covers the capital costs related with building the generation plant, fuel cost, fixed and variable costs related with operation and maintenance, and the utilization rate for each technology, otherwise known as the capacity factor. Generation technologies such as solar, hydro, and wind have very little operation and maintenance costs, so their total cost is almost proportional to their capital costs. This is why they appear as almost straight lines on the graph shown here. From using the capacity of the 2015 generation mixture, we see that the LCOE for the Northwest Territories in 2015 year is about approximately $110 per megawatt hour.
So let's see what's available for solar energy in the Northwest Territories. From the National Energy Board, we get the monthly photovoltaic potential in the Northwest Territories. So let's do a little experiment. What will happen if we vastly increase the solar capacity within the system? Let's say that every single person purchases enough solar panels to cover a roof. Doing this adds about 165 megawatts of capacity to the system throughout the year. But it's important to consider that this added capacity is really only viable over the summer, when the residents have the lowest energy requirements. So by looking at past projects in the Northwest Territories, we can try to estimate the cost of increasing the capacity. Solar has basically no variable costs, so instead we look at the upfront costs. Past data shows that a 25 kilowatt solar PV array produced 22,500 kilowatt hours per year, and that one had a project budget of about $200,000. A reasonable estimate is that over the lifetime of a solar panel, the cost to implement will be about 23 cents per kilowatt hour. While this is a pretty pricey commodity, you also need to consider that the Northwest Territories has one of the highest costs of electricity in Canada at about 30 cents per kilowatt hour. The Northwest Territories has a very small, sprawling, and remote population, making it difficult to implement a standard electrical grid. Solar energy actually makes a reasonable amount of sense, and the government recognizes this. There are programs like the Arctic Energy Alliance that offer funding for those who want to increase their solar capacity.
So what does this new system look like with increased solar capacity? The figure on the left is the old generation mixture shown previously, and the figure on the right is a new generation mixture with the increased solar capacity. We see that the solar capacity is increased to about almost 40%, while the diesel capacity was reduced to about 40% from the original 60%. We see that this has a large effect on the levelized cost for the system. The new levelized cost is almost $65 per megawatt hour, as compared to the previous 110 megawatt hours.
So what does any of this mean? Let's first look at the benefits and challenges that come with increasing the solar capacity. So the end-use demand won't be too greatly impacted. The majority of the energy consumption is related to industrial and transportation applications. Only about 22% is commercial and residential, and that's where increasing the solar capacity would have the greatest impact. The variability between seasons is also a really important consideration. The times where you have the highest solar capacity are also the times where you have the lowest energy demand. And then we consider the savings on fuel transportation and storage. Despite the Northwest Territories having a plethora of natural resources, it's not terribly cost efficient to take advantage of them. Instead, they buy most of their fuel from the southern provinces and then store and use it throughout the winter. Finally, implementing a system even remotely like what we've described here would be accompanied with extremely high capital costs. So is increasing the solar capacity worth it? After taking an extremely aggressive approach, we ended up with reduced dependency on the southern provinces for fuel throughout the winter and more in-province energy generation, which is great. But there were very high initial costs, and due to the variability of solar energy, we had very little energy generation in winter months, despite that being the time when the demand is the highest. Thank you for listening.